Hello, welcome back. My name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to be looking at fraud detection with Python again, and we're going to learn a traditional way that you can uncover and detect fraud using, quantitative analysis, data science techniques, etc. Let's go ahead and see what we can learn. All right, so we're inside Jupyter here. And so all we're going to do is copy and paste over the information that we need and run the analysis. So we're going to start with our libraries and loading our data. The data, of course, is not available except locally on my computer, but we're going to go with this example. So we're going to use pandas, NumPy, and matplotlib. And so what we're going to do is we're going to examine the means. The means of the individual variables helps you to uncover how you can possibly approach setting up your rules for the various thresholds that you might want to set. So what we're doing in this particular line of code is we're grouping it by class. That's our fraud detection variable, whether it's fraud or not fraud. And we're looking at the means for all the variables in our data set. And so we're going to go ahead and run this. And so we've used this data set before. The variables have no real meaning here. They're just V1, V2. And so notice how it's grouped by class. 0 over here in class means it is not fraud. 1 means that it is fraud. And so you can clearly see that there's a difference in the means many times. For example, on average, the score for variable 1 is negative 4.98 when it is fraud, and 0.03 when it's not fraud, excuse me. And so you can see these differences. These are all telling us as indicators of where fraud is at. And so, of course, just because a particular variable has a high or low value does not necessarily mean that it is fraud. So we know our rule is not going to be perfect. However, this can provide us with clues on how we can set up our rules so that we are able to detect fraud with some degree of accuracy. Now, the next thing we're going to do is we're going to set up a visualization of our plots, of our variables. Now, we're not going to do all of them. We're just going to pick 2 for demonstration purposes. But of course, you can look at all of them if you want. Now, I also need to mention that there's lots of different ways that you can examine your variables. We can't explore all the different approaches here. We're focusing more on making the rule than on exploring our data. So what we have here is our code to set up our box plots. So we're taking variable V1, this guy right here, and V3. And so first we subset our data. So right here for variable V1, we subset class when it equals 1, so when it indicates fraud, and we want all the values for variable 1 when the class indicates fraud. And then we repeat this same code for variable 3, or V3. We want all the instances of variable V3 when class equals 1, or when class is telling us that there is fraud. Then we put this together in a simple object called plot underscore data, and then we plot it. That's all we do. And we label it, of course, the x-axis, so we know which plot represents which one. And let's go ahead and take a look at this. All right, so there we go. You can see for variable V1, the median is a little bit below, or a little bit above -5, excuse me. And for V3, the variable looks like it's a little bit below -5. And so this gives an idea of the spread of our data. We could have did a histogram as well. There's lots of different ways to do this. You find what works appropriately for you and your situation. Now we're going to implement a very simple rule. So let's take a look at this. All right. So you can see here we're creating a new column in our data called flag as fraud, flag underscore as underscore fraud. And we're using some methods from NumPy where this is similar to something you would see in SQL. Then inside that we use logic underscore and. So when variable V1 is less than or equal to -3 and when variable V3 is less than or equal to -5, flag it as fraud. Otherwise, do not flag it as fraud. That's what the 1 and the 0 mean. And so you can see again, our median here is a little bit below -5. So it might be like -4 or whatever. Now, how do we get these numbers? Well, with the traditional approach, for our purposes, it was kind of trial and error to try to find the best way. Again, this is how it was done in the past. But I don't want to get ahead of myself, but the beauty of this is that the traditional way is very easy to explain to leadership and other people, even though it might not be the most accurate way to do it. So what we're doing now is we're creating a new column where we're going to flag things as fraud based on values in variable V1 and valuables in variable V3. So we're going to go ahead and do that. So this is kind of like our algorithm, if you will. Now we're going to continue the journey and we're going to print out our information here in the crosstabs. All right, so this is what we got. Let me give you some more information here to make this as clear as possible. Okay, so this is what we have. What we did was we created a crosstab, and inside that crosstab, we're comparing the values of class. This is our original information, excuse me, with our new information, flag underscore as underscore fraud. And of course, the row names is going to be labeled actual fraud, and the column names is going to be flagged fraud. That's what we're looking at. So in our actual, you can call this a confusion matrix, if you will. You can see 4,984 of these were truly negative. In other words, it was not flagged as fraud, and it really was not fraud, excuse me. Then over here, we have 22 true positives. In other words, it was flagged as fraud, and it really was fraud. Over here, we have some false negatives. So it was flagged as fraud. Okay, false negatives. Excuse me, false negatives. It was not flagged as fraud, but it really was fraud. Excuse me. That's the over here. So these are incorrect. And then we have 16 false positives. It was flagged as fraud, but it was not really fraud. That's what's going on there. And so you can see we have some things that we need to work on in terms of false negatives and false positives. That's where our weakness is at right now. So let's continue. I'm going to show you now some more information. This is going to kind of be a rehash of what we just did, but this is going to give us some metrics in relation to different tools that we use for precision, recall, and F1 score. And so the precision recall, they give you an idea of how well your data set goes at producing true positive based on different circumstances. Or there is the total number of true positive, or the total number of things that are flagged as true positive. It gets kind of complicated, and that's beyond the scope of this video. The F1 score is a measure, or it's almost like an aggregated measure of precision and recall, if you will. And so the code for this is very, very simple. This is just to label it. That's all that this is in quotes. And then we have our actual function, if you will, here, classification report. And of course, it's comparing the originals with the predicted values. And then we also have our confusion matrix as well. Down here at the bottom, this looks exactly the same as what we had before up here. That's all that is. And so what's happening here is this is just reinforcing what we already know. We are struggling with dealing with with false positives and false negatives. That is what precision and recall is telling us. And if you see here, those values are very high compared to our overall data. So we have to find a way to improve that. And that's where the weakness is at right now. So again, if you want more details on precision and recall, you can of course always look that up on the net. Now, I don't want to give you the idea that you are only limited to having one rule. You can have multiple rules if you so desire to try to find ways to improve and strengthen your model. So here, we're kind of running the same code again, but this is what's happening. This is our original rule that we made. And what we're doing now is that we're taking the results of this output and we're putting it here. That's what's going on. And now we're adding additional rules to it. So this time I'm adding variable 7 when it's less than or equal to -6. And so what's happened is that take what we learned the first time we ran flag underscore as underscore fraud when it equals 1, because that means there's fraud, and then add this rule. When the value of variable v7 is less than or equal to, or less than, less than -6, not equal to. And then we repeat this process. We take our results from here and we run it down here. So this time when variable 9 is less than 0, basically. And then we repeat it. And so now we have multiple rules. We have 4 different rules, and we're going to see if this helps to improve our model. So we run this. And then now we're going to take a look at this again. Okay, now you can see we're much better. We've reduced the number of, let's see here, false positives by a great deal. However, false negatives have gone up a little bit, and our true positives have also gone down. So we're doing much better on the metric that this right here. And so let's just take a look at our results. Again, this is the same code, just with the updated information. All right, so you can see now our precision is very, very high now, 0.94. The highest value is 1. And so we're very, very good at dealing with, what do we call these? False positives. However, we're still having a problem with false negatives. That's where our weakness is at right now. So when to worry about false positives and false negatives depends on the situation. So right now we're doing a very good job at dealing with our false positives. This is good. So in other words, we're not saying that fraud is there when it's really not there. This might be very valuable, for example, in situations like with medical or whatever. However, with the false negatives, that could also be a problem. For example, a credit card company will be concerned with false negatives because we're saying there is no fraud when there is money there. So a credit card company might want to lower the false negatives, and they might not be as worried about the false positives, because false positives means, okay, we did an investigation when we did not have to, and there was nothing to see there. So it really all depends on the context about whether you need to focus on false positives or false negatives. And keep in mind as well that as you improve one, the other one is going to suffer. So going back here, you can see our recall used to be 0.44 and our precision was 0.58. However, when we improved our precision, almost to, over 0.9, to 0.94, our recall fell as well. So often there's a compromise between as you improve one metric to improve, for example, false positives, the false negative metric will begin to suffer and vice versa. So you have to weigh the two and decide for yourself which one you need to focus on more. All right, let's summarize this video and wrap up. So in this particular video, we looked at a traditional way that you can detect fraud using Python. And so we started by, of course, looking at the means of the different variables we had available. And then we picked two of them, as an example, without really having a strong methodology behind it. And we plotted them. And then once we had a visual of them just to kind of give us an idea of what to expect, we then used those same two variables to set up our first rule here. And so that's what we did right here. We created our rule that we're going to flag things when variable 1 is less than -3 and when variable 5 is less than -5. Or excuse me, variable 3 is less than -5. From there, we took a look at our confusion matrix to get an idea of how we were doing. And we were clearly struggling with dealing with false positives and false negatives. We were struggling with that. And so then, of course, we looked at actual metrics to confirm this. We were really struggling with our precision and recall. And so we went back and I showed you how you can actually have multiple rules that you're able to develop, because Python runs all these lines of code sequentially, one after the other. And so you can just stack them up behind each other and do it like this. I'm sure that's a more efficient way, but this worked for our example. And so when we did things again, we did a much better job dealing with false positives this time, much better job, but our false negatives kind of struggled a little bit. And so from there, we ran our numbers again, and we could confirm our precision was much stronger. Our recall went down even more, which again Whether that's good or bad depends on your context. And from here, we're able to go forward and to continue to work on finding ways to improve our model. So again, the traditional approach is excellent when you need a simple model that you can explain to anybody. Leadership, stakeholders, they should all be able to comprehend what's happening here. Of course, more complex algorithms will yield better results, but then people don't really understand what is going on sometimes, and that could make people nervous, especially if there's a problem that arises and nobody knows exactly what is going on. So, I want to thank you so much for listening and watching. My name is Darren Thomas. I am the Director of Educational Research Techniques. Thanks again, and you take care.